When it comes to just what's the cheapest way to put an electron of power on the grid, wind and solar win hands down, at least if you're in terms of anything new that you're building. If you come to building anything from scratch, those are your cheapest power sources. So as much as we can lean on those cheapest, cleanest sources, we want that to be a big part of the mix. But as anyone will tell you, it's not windy all the time. It's not sunny all the time, and we're never going to build enough batteries to back up or balance wind and solar. So even wind, solar plus huge investment in batteries, those three pieces aren't enough on their own. And so we're going to need a grid that blends in what I call complementary sources of power. We should be keeping, to the extent we can keep them safe and reliable, we should be keeping, in my opinion, the nuclear plants that we have. We should be keeping hydroelectric power to the extent that it can be maintained safely and in ways that are sensitive to ecosystems. And that's not going to be enough, because probably if we're moving to what we need, what a lot of net zero strategies suggest we'll need by 2050, we're going to need about twice the electricity supply that we have today, because the electric cars, the heating, the industry, even if we get more efficient, we're probably going to need to double it. So the nuclear and hydro that we already have, the amount that we might grow wind and solar, even those probably won't be enough. So I think we need to be looking at other options that complement it. It remains to be seen what's going to happen with new nuclear technologies. That we've hardly built anything since 3 Mile Island. It's I think at least 10 years until we have any substantial deployment, or we really know how these new technologies will pan out. But they're definitely worth exploring, but not relying upon. And to me, as I was researching my book, what really emerged to me is as the sleeper technology. I don't want to oversell it because it's not there yet, but I think if I had to sort of put I don't know if you call it a long shot bet, or something that I think it could have a really huge payoff, it could be a much bigger part of the supply than people realize now, is geothermal. It's a tiny share of the supply right now. The way we get it now is mainly from a place called geysers and a few other places where you just got steam emanating from the ground, where it's really easy to capture. But there are new technologies emerging that I think could be breathtaking, that could mean that you could get geothermal power across large swaths of the Western United States at first. And even some of the technologies would make geothermal electricity accessible across even more vast parts of every region of the country. So it's not there yet. It's just being deployed. Department of Energy runs a Forge site, it's called. I believe it's in Utah. We probably need several sites like that to really test out technologies that are emerging. But that's one of those things where if it has the potential to hit those learning by doing curves that solar and wind got on, where just people who don't realize that power of learning, that power of technology diffusion, I think are missing where that might take us. Is it would take another sort of factor of 2 cost coming down, like we've seen more than that for wind and solar, and it could get us there. And I think as a Texan, what I like about that is that it puts to use some of our legacy industries that are seeing their traditional markets decline. Is that we have a lot of oil and gas drillers, where we have a lot of drilling rigs staying idle. We have a lot of horizontal drilling technologies that have been pioneered here, and would love to see horizontal drilling done in a way that lets you tap into broader pools of geothermal heat, and really opens the possibility of getting electricity in a way that we never have before, and in a way that doesn't depend on the whims of the wind and sun.